In this lesson, we are going to be talking about a new term for most of you, which is called standard deviation. And we're going to state what standard deviation does to a data set and how we can interpret data using standard deviation. Standard deviation tells how close numbers are to each other. In other words, it's talking about the spread of the numbers, how far or how close they are apart from one another. When you see the symbol sigma, it is a Greek letter. It stands for standard deviation. The closer the standard deviation is to 0, the closer the numbers are together. For example, if you were to have a standard deviation of 0, your data set may be something like this: 5, 5, 5, and 5. These numbers are the exact number, so they are not spread apart at all. Therefore, they have a standard deviation of 0. Now, if you were to have a standard deviation of 5, I'm not saying this is an exact set, but this might be somewhat of an example. If I started with the number 4, and then I went 10, 16, and 23. The numbers aren't huge difference apart, but they are spread apart a little ways, and so therefore they have a standard deviation that's a little larger. Now, if you were talking about a standard deviation of 20, that would mean that the numbers would be quite spread apart. For example, if I had the number 4, 16, 32, and 101, they would be quite far apart, and so they would have a large standard deviation. Some also call it that the standard deviation determines the spread, how far they are apart. It also can be how close they are to the mean. Because when you have a mean of a data set such as this, with the numbers that are exactly the same, if I add them together and divide, my mean is 5. So that means that the closer the original numbers are to the mean, the smaller the standard deviation, which also means how far they are spread apart. Let's look at an example. If Sarah and Beth have the same mean points, that means they have the same average points scored per game, but Beth has a standard deviation of 3.2 and Sarah has a standard deviation of 1.4. Which player would you want on your team? So, Beth, 3.2. That means that when we take a look at her scoring, her data is more spread apart. That means sometimes in a game she might do really well, sometimes she might not do very well, sometimes she might be right in the middle. So when we would put all of her game points up, she would be a little bit spread apart. On the other hand, Sarah, who has a standard deviation of 1.4, she would actually be a more consistent player because she has a smaller standard deviation. Her scores would not be as spread apart. So, which player would you want on your team? I would suggest that you would want Sarah on your team. Because she is a more consistent player, her scores are about the same each game she plays. She doesn't necessarily have one game that's poor and one game that's really good. She would be more consistent. This is an application we can use for standard deviation. In review, remember that standard deviation tells how spread apart the numbers are to each other. Would you please remember to complete the reflection, and remember the closer to 0, the closer the numbers are to one another.